Welcome. It's a Friday evening. I have some Adafruit stuff and some more of my ESP adventures. Um, and I'll hide these above the screen here until I'm ready to talk about those. So first we're going to look at some Adafruit stuff. And this time, I guess they're running out of boxes because they put all my shipment into a bag this time. Either that or they're getting environmentally friendly and decided they don't want to ship so much cardboard. So that is my set of sheets, and I'm going to put it in the drawer. Let's see if I can get it under the capture device. Okay, so what do we got in here? It's like a grab bag of magic. I think I have to do a clean job on my surface here. So, I'm pretty sure that this is the free item right here. Now, this is... So, I only had, I think, one of each, of a 3 and a 2, I think it was. These are feather... So you don't have to stack feathers on top of each other. You stack them side by side. So these are the kits. So I got a bunch of them because I wanted I got a lot of feathers that I can play with. So this is a quad. Another quad. And this is something else. It's the 4th quad. And what else we got here? Nope. Here we go. This is a triple. And a double. Nope. And this is the free whiteboard. They finally got to give putting more of them in the thing. And this is a triple. Nope, no more left. That's it. That's all it is. So we got those. So we'll put those again. So I got 2s, 3s, and 4s. Now there are 2 different 4s. So you can see this. This is the long 4s here. These particular ones are... Okay, this is a dual. It's like this dual, but it's side-by-side dual, I think. Or it's quad. No, quad 2x2. Quad 4x1. And then this guy here is another quad 2x2. Okay. And then this is triplers. Okay, so all those. And I seem to have junk collection here. And then I picked up a HDMI DVI decoder. I have a screen here somewhere. I just got to find it. That has a proprietary one on there that I can't talk to, so to speak. This one you can. So, and I believe I have the right ribbon and everything for it. Yeah, so 48-pin TTL. I have a small screen, like about yay big, that I can use with this one. Okay. HDMI port, blah, blah, blah. You can talk to it. This ought to be interesting. So I haven't made much use of that screen, and I want to do it. So if we go off to here... And yeah, we have that screen. In a sec, we have parts in the way here. Can't move my mouse. So where's the spreadsheet? It's not in there. It's in here. So we're in the other Chrome. So let's try that Chrome. Where is the Mr. Spreadsheet in here? Really? Where is Mr. Spreadsheet? Okay. Maybe it is in the other one. Yeah, I'm missing the spreadsheet. Oh, that's okay. We can go like this, and where's sheets? And boards and stuff. There we are. Okay. And then we need a Adafruit thing, so we can look at Adafruit stuff. I'm going to flip back and forth. So 2219 is what we're at. Did I not just click this? There you go. Yes. What a way to recopy. 2219. This guy here. So I'm going to put that under miscellaneous stuff. Sensors, other, I think I'll put it under LCD. Control V, and it is 2219. I have one of them, and no, it's not a kit, and yes, it's assembled, and no, there's no stemma on it. This is not a microcontroller board. So we have some sensors here. So we begin with 4681, and I think I already have 4681. This is BH 1750. Yeah, I already have that. So we now have 3 of these. That's the freebie. And then we have Cutie Pie RP2040 is what I actually didn't have. And I found I ran into an issue. I put a display on it and some sensors, and I ran out of memory on the controller. The M0, whatever, it's too small. When I moved the whole thing over to a Pico, worked fine. Okay, so we have 4 of them here, I believe. Yeah. Okay, so 4 4900s. So let's go to 4900. 4900. This guy right here. Control C, and we know it's a microcontroller, so we'll add it to the microcontrollers. And Control V. Whoops, Control Z. How about we go Control V up there, because then it'll plain text it. And this is 4900. We have 4. And yes, they're a kit. And no, they're not assembled. And yes, they do have stemma QT. I'm pretty sure they do. Yep, they do. So we do have stemma QT on these. Okay, so those 4. Then I have this, which is a saw clip for debugging things and stuff like that. As Lady Ada says, don't put it on your finger. It hurts. It'll poke holes in it. Yes. Okay, so this is miscellaneous stuff. And we'll go down here. And this is 5315. So 5315, this thing right here. So if you screw up one of these boards, you need to directly connect to it and blah blah blah, you can do it with one of these things. And spreadsheet, Control V, and I said 5315. Yeah, 5315, and we have one of them, and it's not a kit, and it is assembled. And no, there's no stemma. Okay, so that's that. And then I was interested. It's not very cheap, but I only got one of them. But this is I have another micro GPS unit that's a standalone, but this is actually a feather with a GPS wing thingy on it. So I'm gonna 3133, 3133. So I got one. 3133. This thing right here. Control C, we'll put it in here, and it goes into microcontrollers. And we will Control V, home, and I hate it when the thing has. Oh, there we go. I got a extra carriage line return in there. One. Yes, it's a kit. No, it's not assembled. And is there stemma on this thing? I cannot remember. Nope, doesn't look like there's stemma, but there is a spot for an antenna. Yeah, no. Nope, no stemma. Okay, so no on the stemma. Okay. Then I wanted to kit a couple of these things, these little Geminis. They're kind of like the playgrounds, but they're smaller and tinier and funkier. There's a battery thing on it. A bunch of chips on it. These things. So 1222. 1222. This guy. And yes, it's very tiny. So I'm going to add that in here. Whoops. That's I think where I'm getting the space from. Right there. Control C and we'll go off to the spreadsheet. There, yeah, that's better. And so I said 1, 2, 2, 2. 2. No, it's not a kit. Yes, it's assembled. And there's no stemma port on these guys. No. Okay. Now, I did get from AliExpress some stuff too. And I put it all together already. So these are little ESP boards. So we got a couple of varieties here. So this guy here is 8266. And I've done it two different ways. So I have stacking headers on this one, non-stacking headers on that one. Now, these guys were this brand, and I put this on the top on this one, and then a stacking header with one set of row of pins on this one. I might sit there and put on this one right here another set of female on there to do it. You can't do two sets of stacking headers on this one. Okay, and then this one here, there's the female header on it. It's the same basic board, it's just slightly different manufacturer. In fact, you look at it here, they look pretty identical, right down to slightly different chip used there, but otherwise basically identical. Now the other one of this, I have two of them. And what I did is I wanted it for was this board. I put it right here. I used to have my one and only new Nano, this guy here. This is the Nano RP24 Connect with lots of stuff on it. And I didn't really want to waste it on this board. So instead, I changed it out for this board. I had to wait a while because I had to get these style of boards. So both these styles of boards fit on here. If I pull this one off, I can fit this one on because it has a spot on here. And depending where you put the pins on here, you get different pinouts. And they actually show up here, I think, and down here. If yeah, there, down here, and then up here. So now I don't. There's some other boards that go on here. So over here is supposed to be a board. I don't have that board. This one right here, technically I do. This is an LCD panel, a 16 by 2. It's one of those rectangle things. And then over here is supposed to be a stepper motor driver board and a step-up module. And I was looking for that. I haven't found quite. I think I ordered some. Well, let's see if they fit. And then this one here, right here, I believe is another board. What's it marked out? Yeah, it's like what they consider BRD2 or something like that. And then here, there's another one that said DC to DC module or a battery shield. Right, and I filled in the rest of some of these things down the side, so you can put sensors and stuff on here and directly access them. I haven't figured out everything yet, what you can and cannot do. And they do have a whole bunch of wiring on the back. So this is similar to another version of the board I have, but this one's really for ESP. And the other one I have is really designed around Arduino. And you have all this breakout here of what pin goes to what and stuff like that. And it's all marked. All very well marked. So that is basically all of these things. And I think one thing I haven't done, so I'm going to leave these somewhere else, is I haven't cataloged these yet. I need to do that. These are not Adafruit cataloging, so I think I will put all of these in that bin down there, along with all of these, like so. Okay, and I'll just put this board up here to get it out of the way. I also, Grove connectors, I picked some up. So there's both male and female in this bag with pins for making Grove stuff. Okay, I'm just going to put all these guys over here. And that guy can go over there. Now, our ESP32 S3 Dev Kit C1N8. I finally figured out what the R8 is for. So this has 8 meg of storage plus 8 meg PS RAM. So the R2 is 2 meg of PS RAM, and the one without anything on the end is just pure regular storage. Now, if you're going to ask me what the PS RAM's for, I can't tell you yet. I haven't figured that part out. But I did figure a bunch of things out. Now, what I want to do is rearrange my ESP folder on this machine. So let us go here and go to work. Where's my work directory? There it is. So I have this ESP IDF folder with projects in it. We're going to change this. So we're going to create a new folder here. And we're going to call it ESP32 S3. And I'm going to shorten the name a little bit. And I'm just going to call it N8R8. So off my projects, I'm going to create it based first of all on board name. And these two blinks, we'll just leave alone for a moment. We're going to redo this one. Okay. So we come up to our Visual Studio Code. Now, I found basically step one, you really have to do this their way. So open a folder first before you do anything, right? And we go to work, and that's the wrong projects anyway. Go here, go here, go here, and say OK. So we start out in this, but we don't have an actual program yet. Then we can go to ESP selection. And what we want to do is show example projects like I did before. We're going to do it in here. And I'm going to borrow the Blink program again. And I'll create using the thing. And I'll do it in this folder. So now within the ESP32 folder, we'll just do that. We'll allow the C extensions. I don't have Docker, so I don't know why they prompted me on it. I'm just going to turn it off for this folder. Okay. And I'm going to stretch this out a little bit so it's a little bigger. So now we have all this. Our VS Code directory has all its stuff in it. But we don't have a make workspace file yet. So, and we haven't set our port up very well either. So first of all, I'm going to save a workspace out. And I'll call this ESP32S3N8R8. And we will be putting it in the Blink directory. Okay. Now, of course, we can change this port down here like this. Right? But we haven't plugged our board in yet. So let's plug our board in. So, according to the ESP guys, I need to use the upper UART/board because the lower one's not programming properly yet. Okay. So let's try changing again. So we now have T2ISO USBO and Acme. So it's USBO. Okay. Now the problem, of course, is even though I changed it here, and in theory, it's here. Okay. It actually doesn't work. It might do it once, but otherwise it won't do it. So what we're going to do, and this bash cmake build bash shell, no, we don't want that one. We want a IDF ESP terminal, like so. Okay. Now I'm just going to go back to my other Blink program, the older one. I just need to know what I put into the VS Code settings file. So I'm just going to open it up in Notepad here. Okay. So over here, we have to make sure we take ESP32S3 ESP programming JTAG. Okay, so it adds all this stuff to it. Now we want all this, Control C, and we want to open up the workspace, and this settings thing right here. Okay, just like that. Now there's a square bracket floating loose. No, that's fine. I mean, you can do this. That'll work also. So now I have this all in here. Now when I build, this will be correct. Okay. Now reason I want to bring the Blink program wow, frogs in my throat, up is because I finally figured out how you mess with the LED on this ESP board. It really isn't straightforward. Let's bring in the Blink. Yes, and I still haven't fixed this part yet. I'm pretty sure I have to figure out the damn Visual Studio tag problem with syntax highlighting and all that stuff. It's not, IntelliSense is not doing its job 100% correctly here. Some of it is like that, but others it's not. So when we look at this code here, okay, whoops, didn't mean to do that. This sets the initial state for the LED. Now there's two modes you can blink this thing in, what they call GPIO mode or RMT mode, and that's what all this is about. So really what happens, and they could use better comments right here, this is RMT mode. Okay, so it figures out if it's in RT mode, sets some stuff up, does a function, sets a function up, blink LED, sets another function up, configure LED, right? And then end if, else if the GPIO, then set a different blink LED, a different configure LED, and come down to the end. So right here, I am going to put in GPIO mode, like so. Then we come down, and what actually happens, depending which state this thing is in, we're going to run whichever blink LED code. Okay. Now, one of the problems is, how do you know which mode you're actually in? Well, if you go here and you go to this wrench, you bring up their configuration editor, this guy here. So if we search LED, okay, you can choose GPIO mode, RMT mode when you find this parameter, example configuration, blink LED type. So I had it in RMT mode, but I also found out there's a GPIO here too, example configuration, blink LED type, and you're looking at this and going, what the heck? Didn't I just do this one? No, they're actually two different ones. Why they're like this, I haven't figured this part out yet. But anyway, you do this. This is the pin 48, and you say save. And it actually gets saved in these SDK files right here, the SDK config. Okay, so you can now close this guy off. And what we'll do is, first, trash can, clean it clean. Then we'll build. Something wrong. Why? I should be able to do this. Sure, I picked the right one. Yeah, ESP3. Blink. Okay, try to build. There we go. There's a manual function called IDF space set dash device space, and you set that. So it didn't take the first time. This. If that's the case, you get that error, just redo this command. So we built the code. Now we'll push the code into the flash device. Okay. Now when we look at this, we are blinking. So watch the rate of this blink. Okay. Now in our code here, this is the line that's actually causing the delay. Right here. I am going to change this because I have not found out where the config blink period is set yet. But what I'm going to do is change that. I'm just going to put a manual number in here. I know by default it's 1,000, so let's change this to 100, like so. Okay. And then we go and build again. And it's only compiling the stuff that actually changes. So now our incremental building is working good. We're not building the whole thing again. And then we push it up. Okay, now we change the blink. Finally. So now that actually works. So we are modifying, but it's quite the block of code just to do this. I had to fiddle a lot with that config option to change the card. Change the microcontroller on the inside and then the SDK config. I still haven't figured why there's two sets. Like if you search for LED, you'll find one set of configuration that you can pick RMT in, and if you pick GPIO, you can pick a different one. Right? I don't know why. So I haven't figured that out. But I have found in Discord. So normally the Adafruit Discord here deals with CircuitPython. You can see all this down here, right? Okay. CircuitPython 3D, Adafruit IO, Arduino, right? Well, I added in the official Express site. So this is the actual complete, whatever. I've read and agreed, submit. There we go. A lot of times when you join a Discord channel for the first time, there's a waiting period. So they can catch people not spamming. So we do have actual, apparently, ESP mods in here from them. And they do have channels for S3, for example. So I am going to probably be asking questions in this channel. I highly recommend that you join at least 4 channels in Discord. Join the Microsoft Community channel to ask Visual Studio Code questions. The Arduino channel to ask, of course, Arduinos. The Adafruit channel to talk Adafruit. And, of course, the Express. And optionally, join the Python channel if you want to have generic Python questions. Right? If you try to ask microcontroller and CircuitPython, they're going to tell you to go to Adafruit site to talk up there. But so that is cool. I now can actually program any one of these, even these little guys here. Now the only thing I've done on these ones is to test my code pushing into here, but I haven't got the LEDs to blink yet. I'm still figuring that out because apparently the LEDs are not where the LED on this one is. So that RMT and that GPIO, it's marked on here, for example. It says GPIO 48, for example, for this LED. And this is not, this is like a NeoPixel. You can change the type of color and everything on this, right? So, but there's 2 LEDs on this board down in this corner here. So now I did ask today on Deep Dive with Scott, and that apparently Arduino mode for these S3s is coming. It's just still not ready yet. And I also saw hints on the Express site that version 5.0 of the ESP IDF is also coming. Although I don't know if it's done yet. So, but if you're going to work on any of these, as I said before, release 4.4. You need to use that one. So, that is my coding for this. Probably tomorrow I'll do a bunch of soldering. I will put together the feather boards. And now that I have the cables for all this, I need to do some more work on this one here. This guy here. So I'm really happy with this board with the attached Pico and then the Grove headers. It's really easy to do the I2C stuff. Like 6 I2Cs right here. And of course these chain off of each other. Right? Which is really neat. Now I've got the little ESP teeny weeny that's coming for this connector. Right there. So you plug it onto it. It's a stupid tiny little board like that. You plug it on there and it gives this system Wi-Fi. It has an SD card reader already. It has a speaker. It has audio. And it has all these buttons. And it has this guy here, GP28. So if I put the light program on here, I can make this do things. And of course, they put all these indicator lights on here and everything to tell when you're using a particular part of it. So I did get the screen working. The sensor's working. I can pump data out of it. What I'm trying to do now is send the data to the screen. Oops. Here we go. So I got this screen, which is a 1.5 128 by 128 OLED display. So, and then I got my particle sensor. This thing has a little fan thingy in it that when it runs, it sucks in air and it counts, I don't know, particles. Like if there's crap in the air. You know what I mean. But yeah, I wanted to run these 2 devices in a chain. So off the back end of this would be the screen, for example, and run it off the Cutie Pie. Except I had the wrong Cutie Pies. Not enough room in them. These have more. This has a lot more room in it. Now it would be kind of neat to run it all off this one too, because this has a lot of room too. We're talking 8 meg of, I think, storage and 8 meg of PS RAM, whatever that is. Haven't figured that one out yet. I have to read more of them on it. But yeah, the neat thing about this one is, unlike Python ones, is that I'm safe to hit the reset key on here. Like this one here, if I hit the reset key, right, it just restarts it. I don't lose track in the browser or any in the Studio Code or anything like that. It's still there. Whereas these ones, yeah, if I hit the boot button on here, I will disconnect the drive, and that might cause a drive corruption, blah, blah, blah. That's the only downfall I find on the CircuitPython stuff, is that you have to be careful in dismounting the drive properly and stuff. Yeah, and be careful, too, of unplugging I2C devices from here. You can cause this to reboot just by unplugging this. It's sensitive to, I think, to power changes. Right? So it can cause a reset. But that should be it. This is not a long video. It's just a good video. Well, I don't know if it's good or not. Put this back in the box here. Like so. There we go. So that's will be it for the evening. As I said, tomorrow I'll probably do some soldering. And we'll find out. So, toodaloo.